Hello, my name is Nathan and I'm here to talk about ice cores. Now, what is an ice core? Well, an ice core is a cylindrical piece of ice. It's anywhere from less than a meter to several hundred meters long, and it's usually less than half a meter in diameter, usually, 10, 15 centimeters in diameter. It's drilled and extracted using a tool called an auger. And what an auger does is it cuts a really, really deep hole into an ice sheet and then clamps the ice that it's then cut and extracts the sample. So you have a nice cylinder piece. You can see it in the photo. Except this thing kind of goes way down into the water or into the ice sheet, and then it pulls out and you get a great sample. These ice cores are generally drilled from places where you can find really thick ice sheets like Greenland, Iceland, Antarctica, the North Pole. It also is kind of it's kind of a requirement that these ice sheets have been relatively stable, not too much melting in the last few thousand years, and that they have been around for several thousand years. After being extracted, ice cores are generally stored in a warehouse where it's kind of like a giant freezer, it's a giant scientific freezer of information. One of those kind of ice core labs will look like this, with just hundreds and hundreds of ice cores. Now, after you collect your ice core sample, use the information you get from there, and you can use it as a proxy, right? So then, what a proxy is it's a taken data set that is then used to correlate other information about related climate factors. Now, for example, if we see a series of very thin layers overlain with ash and a lot of sulfur trapped in some air bubbles in the ice, then we can use this proxy data to infer that there was a volcanic eruption. Now, if there's a lot of carbon dioxide trapped in the air bubbles and the layers are very thin, then the thin layers is surrounded by a bunch of other thin layers, then we know climate was a little bit warmer than normal because, there's less accumulation of snow. There's a lot more melting due to a strong greenhouse effect, especially if you can find a lot of CO2 in the air bubbles. Now, you can think about a proxy as essentially a primary source of data that's used to correlate secondary data. Now, ice cores can tell us a lot of information. Using the bubbles found in the ice cores, we can then get oxygen isotope ratios that will tell you whether or not there was a lot of melting, whether or not there was a lot of precipitation, accumulation of snow, because certain oxygen isotopes tend to come out of the atmosphere in the form of precipitation faster than other oxygen isotopes. Some would rather stay in the liquid phase rather than turn into a water vapor. Another thing is the thickness of the layers. In this graphic, we get a really good view of all the different layers, right? So these are nice thick layers, so you know that there's a lot of accumulation at this point in this area in this time period. Now, if you have really, really thin layers, say, I guess these are all pretty thick, but if you had a bunch of really thin layers, you would know that there wasn't much accumulation. It was probably pretty dry, or it could have been warm. I can't really tell from this photograph, but you can test the different thicknesses and see if it's thinner or thicker. Now, ice cores can create a window into paleoclimate and show scientists what the world may have looked like if there was no anthropogenic climate change or pollution. It also shows us what would be considered normal for changes in atmospheric composition and temperature. Now, I know what you're thinking. This is just a bunch of scientific mumbo-jumbo. Nobody really cares. Well, let me tell you why you should care. We all know about climate change, and whether or not you believe it, it's your choice. Ice cores give such detailed information regarding the past climate that we know current carbon dioxide levels and their down. The current carbon dioxide increase rate is just beyond anything we've ever seen occur naturally. Along with that, our warming is going up exponentially faster than anything we've ever seen in climate. The evidence for climate change is irrefutable, and ice cores are one of those damning pieces of information.